Welcome to this video. I'm going to be going through some pseudocode examples from the GCSE AQA papers of 2018, 2019, and November 2020. Example of different questions. We're going to start on basic questions and then we're going to build up the complexity as time goes on. What I suggest we do is that you can pause, attempt this question, and then you unpause, and then I'll start going through what I think the solution is. We should work together like that. My advice wouldn't be just to sit back and watch. Is more engaging you make it, the more you try and interact with it, the better it will be. So without further ado, let's get started. So the pseudocode in figure 1 assigns two string values to two variables. So first variable is named title, and it's storing the value computer science. It's a string because you can see it's between these quotations. The second variable is identified as level. So the name of the variable is level and it's storing GCSE. And remember, the arrow assigns the value to it. This is trying to make sure you understand the difference between having a name of a variable and the thing it's storing. So let's get started looking at the first thing it's asking you to do. So it's saying shade one lozenge, that's one of these things, that shows the length of the contents of the variable level. So level's this one. And the length will be this. So remember, it's if it was identifying the position, it would be 0, 1, 2, and 3. But there are 4, 1, 2, 3, 4 letters long. So the first answer will be 4. Let's continue. Shade 1 lozenge that shows the result of concatenation. Now, concatenating is when you stick strings together. So when you use a plus with a string, remember, it doesn't do a mathematical add. Instead, it sticks it together like glue. And it says concatenating title, so plussing title to level. So something on the lines of title plus level, that sort of effect. Now, you might be reading it and going, okay, well, I see it's all lowercase, so it's that one. It's GCSE, so it's that one there, because that reads the best. But remember, that space there is also a character. Is there a space at the end there? No. Is there a space at the beginning there? No. So when you stick it together, there is a space between computer and science. You see it's up here. However, the rest is all glued together. So it would be the bottom one. If you wanted to introduce a space, you either have to add a space in here, or put a space here, or I guess here. Okay, onwards and upwards. Shade one lozenge to show which of the following strings is a substring. So that's a string that fits inside it. So a substring is any small part of it, of the variable title. So title is here, so that's the full string. A substring, well, put would be a substring. Omp would be a substring. Computer would be a substring. So comp ski. Now, comp appears here and ski appears here, but they're separated by uter and a space, so it doesn't work. Pewters, well, you got pewter, but then there's a space and an S, so what would be that? Ski, so there you go, SCI, that definitely is a substring. And then terra ski, again, there's a space, so it's this one here, it's ski. So a substring is a continuous list of characters inside it. And then finally, the Unicode character of title 0. So remember, we talked about this before, that although, for instance, level is 4 characters long, G is at position 1, C is at position 2, S is at position 2, and E is at position 3. It'd be the same here. That's 0, 1, 2, 3, etc. So let's have a little read of the question. The unique character of title 0 is C. There you go. Is 99. So when you turn it into the ASCII, it's 99. Shade one lozenge to show the Unicode character of the level 3. So level 3 is 0, 1, 2, 3, E. So if C is 99, what's E going to be? Well, D, remember, these are all continuous. So whether it's ASCII, which is 7 bits, all of them are one after each other. And if you remember Unicode, for when you want a bigger character set, the first 127 characters are the same as ASCII, so that you can it's more compatible. So C is 99, D would be 100, and in this case, E would be 101. So in that case, it's going to be this one, C, which is 101. Okay, continuing on, another basic question, mainly looking at things like inputs, outputs, assigning a variable, sometimes with selection if statements, those sort of problems. Let's have a look at this one here. So a cake recipe uses 100 grams of flour and 50 grams of sugar for every egg used in the recipe. Okay. Figure 3 shows the first line of an algorithm that will be used to calculate the amount of flour and sugar required based on the number of eggs. So this thing up here being used. The number of eggs is entered by the user. So that means that user input, so the user types something in. Remember, the arrow is then assigns it to the variable eggs used. Okay. Shade one lozenge to show which of the following lines of code correctly calculates the amount of flour needed in a gram. Now, remember up here we said, it said a cake uses 100 grams of flour and 50 grams of sugar for every egg used. So this is for the amount of flour needed. This is kind of abstraction. So the crucial thing we're looking for here, that's removing the unnecessary detail and keeping what's important. Each egg requires 100 grams of flour. So the key here is the number of eggs used. If we times it by user input, it's what the person's typed in. But eggs used has already been taken as user input. So if you had eggs number used times by 100, it will give the amount of flour. So that seems right. The times by 50, well, that will give the amount for sugar. But we want to know the amount for flour. So it's this one here. Next question. Shade one lozenge to show which programming technique has been used in all of the lines of code. Okay. So assignment is assigning a value to here. The other thing that could happen is that you could be using the sign equals, and that is comparison. So that assignment is assigning a value, equals is comparing one thing to another. Indefinite iteration, so that's when you're using a loop, but you don't know how long it's going to go on for. So that would be kind of a while loop or do until, some kind of logic. Maybe how many times do you have to repeat until the password is correct? That would be indefinite. Nested iteration, if you remember, so that would be iteration, so that would be a loop. And nested is when you've got a loop inside of another loop. That's what nesting is. And selection would be if and else statements. So no if and else here, no nested iteration or iteration of any kind. It's assignment. So it's these things here. It's assignment is the answer for this one here. Okay, I've kind of chopped off a bit too much here, but it gets the general idea. If you remember, one of the crucial ideas with variables is that they belong to different data types. Now, the subroutine in figure 10, we can't see it, but uses the values true and false. So there's a certain data type that is true and false, and we'll try and remember that. And it says each element in the array board has the value 0, 1, or 2. A bit of a recap. True and false. Do you remember what that is? It's a Boolean. So this is a Boolean, spelt like so. You can only store the values true and false. Now, 0, 1, and 2, well, that's going to be one of two things. So there's numbers where it's 3, 9, 10, whole numbers. But there's also numbers like this, 2.6, 7.1, 2.33, where there's a floating point. Whole numbers, that's integer. If it's got a decimal place like this, well, the generic name is a real number, but also acceptable will be, for instance, the phrase float, short for floating point. See here, they're all whole numbers, so the answer would be integer. That's a little bit of a recap. Let's remember what some of the other ones are. What have we got missing? Well, if we just had a single letter like C or X, etc., that would be a character. What else have we got? Well, of course, we've got things like Bob, for instance, where it's a bunch of characters strung together, and we call that a string. And the one we got missing, of course, was the one we've already done, which is Boolean. Okay. The developer has taken the overall problem of the game Battleships, again, we haven't seen this, but it doesn't really matter, and has broken it down into smaller sub-problems. So when you have a big problem and you want to solve it, You break it into smaller subproblems that you try and solve. If they're still too big, you break them down again until they're easy to solve. Very, very powerful technique. But what's the name of that technique? The name is decomposition. You take a big idea, you break it into sub-problems or into smaller ideas, which might be broken down again until you can solve all the individual problems. And then you've solved the whole bigger problem piece by piece. Okay, we're moving on a little bit further now. And the problem we're looking at is going to be not asking us to write code at this stage, but to be able to read code. So this is some pseudocode. This is an algorithm. And part of what we're going to need to be able to do is figure out what's been asked of us in terms of what we've been asked to do. Okay, so let's have a quick read. So we've got a developer creates the algorithm shown in figure 8. So that's this algorithm here. To provide support for users of a new brand of computer monitor. Okay. So it outputs a message to the user on line 1. Can you turn it on? Then the user responds in some way, and that's assigned to the variable ands. In fact, why don't we zoom in a bit so we can see it? Okay. If the answer equals no, so if they entered no, so no, I can't turn it on, it says, okay, the message is it plugged in? And then you respond again. And if you said yes, it has been plugged in, it says, okay, contact supplier. Otherwise, well, you should plug it in and then start again. Well, what happens if you didn't answer no? Well, if you didn't answer no, so let's say you said yes, for instance, you come down to this line. So you'd skip this bit and go to the else. And then it says, is it connected to the computer? If you said yes, contact supplier, else contact the computer. Okay. So this is using outputs, inputs, and if and else statements, which you can see here. Do you remember what that's about? That's selection. So this is sequence, one thing after another. Selection is actually sometimes it will run this line, sometimes it will run this line. So it selects which bit. For the future, so when we get to there, the third thing was iteration, and iterations around loops. Oh, in fact, it's going to come up right now. Very handy. So let's review this first question. Okay. So shade one lozenge to show which programming technique is used on line 3. So this is line 3. Okay, so if ans equals no. Now, is that assignment? No. Assignment's this one here with the arrow. It's assigning the value. Okay, so that's not happening. Is it iteration? Now, do you remember I was just saying now, iteration is when it repeats. So that could be a while loop or a for loop or a repeat until loop, but none of those. It's selection because it's doing the if and else answers. So the next one we've got here is shade one lozenge to show the data type of the variable ands. So ands is going to be here. Is it a date? Well, one of the things it could be is no. So that's not a date. It's not expecting it to be. Is it an integer? You remember from the previous question, integer were whole numbers. So no, it's not that. Is it a real number? Well, a real number, as we discussed, is a number with decimal places. Again, no. Is it a string? Well, no or yes, that is a string. So we should write down here that it's a string. Okay. Regardless of what user inputs, the same number of output instructions will be always executed. So what it's saying is, no matter what the user inputs, right, whether it's yes or no, it will always do the same number of outputs. State how many output instructions will execute whenever the algorithm is run. So let's have a quick look. I'm going to highlight in, I think, highlight in green every time we see it happen. So output. So that first output's always going to run. So that's 1. Then it's going to say, if answer is no, then do this, else do this. So it's saying it should always be the same. So let's assume they've answered no. So then it will say, is it plugged in? So that second one, it's either going to be that one there, it's going to be that one there, or that one there. But we won't count both because only one is either going to run that because the answer was no, or it's going to run that. And then finally, it's going to do either this one here or this one here. So it's going to be a third one, okay? So the answer will be 3. Whoops. The answer will be 3. Hopefully I can do it properly this time. To prove that one's always going to happen. But let's say we answered yes. Then we come down here. Then it will output the second one. And let's say we said yes again, third one. So it's always going to be 3. Okay. The phrase contact supplier appears twice in the algorithm. So here and here. State the 2 possible sequence of user inputs that result in getting here or getting here. So I'm going to put a little red dot to say we're getting either here or here. How did we get there? So the first one, so sequence 1, is that you'd answer, and if the answer is no. So the first thing is that you'd answer no. So it will be ans equals no. And then, so that'll get you inside here. Is it plugged in? If you said yes, then it'll get you here. So the next thing will be ans equals, what was it? Yes. The second one is to get down here. So it's saying anything that's not no. Because its answer is no, then here. Here you could put down anything. It could be like blob, and then because it's not no, it's there. So ans equals anything. In fact, you could say not no. So it's anything but no. And then once you're in here, you'd have to say ans equals yellow. Ans equals yes. Gosh, what's wrong with me? To get to that one. All right, great stuff. Now, final bit. Another developer looks at the algorithm shown in figure 8 and makes the following statement. Okay, so we have to review this. At the moment, if the user enters Y or N, they will sometimes get unexpected results. So if they entered Y or N, so it says, can you turn it on? And you say Y instead of saying yes. Explain why this problem could have been avoided. Explain why this problem has occurred and describe what happens if a user entered Y or N instead of yes or no. You may include references, line numbers, but you do not need to include any additional code in your answer. So let's review. If I answer, so the first one here, answer, it's expecting me to say no. But if I said Y, then it's going to be this. So that's the equivalent of yes. What happens if I answered N? Is N the same as no? It won't be. So it'll still dip down here. So you could say something along the lines of line 3 only, in fact, why don't I say line 3 if statement only works with no string, as in the string being no. N will skip to line 11. You should accept N or no, as well as Y or yes. Because that way, for instance, here if it said if answer equals no or ans equals N, then do this. And maybe here you could even do else if for this one here. Or here if answer equals yes or Y, for instance. Okay, we're now at the point where we're going to start writing some code. And it starts off really simple. On the right-hand side here, I've actually put some snippets of code that we can use. Again, we're going to start off basic inputs, outputs, variable assignment, and some basic if or if-else selection statements for comparison. Okay, let's read the question. The developer wants to use validation, so that's checking whether something's accurate. So it might be It might ask you to put your age in, and is it between a minimum age and a maximum age? So it's trying to eliminate mistakes. To ensure that the user can only enter a positive number of eggs. So in this case, the number has to be, above 0, i.e. 1 egg or more. So you can't put down, you want to put in -3 eggs or 0 eggs in this case. The maximum number of eggs that can be used is 8. So the number needs between and inclusive of 1 and 8. Develop an algorithm using either pseudocode or a flowchart so that the number of eggs is validated to ensure the user is made to re-enter the number of eggs used until a valid number is entered. Now, I've not included it here, but if you keep on needing to enter it until it's right, you can't just use an if and else statement, because the if and else will only check once. You are going to have to do you are going to have to make use of indefinite iteration using either a while loop or a repeat until loop. Now, in this case, I'm going to use repeat until, I think. First of all, I'm going to ask the person, I'm going to write print. I'm going to ask the person, please, enter number of eggs. So I've done the statement here, please enter the number of eggs. Then I'm going to need a variable to store the response. It should be sensible name. So eggs makes sense, right? Because that's what we're doing. To assign, it's the arrow. And the command to get in somebody to input it is user input. Now, the color coding is not necessary if you do these questions. Just so you know, I use blue for commands like this. I use green for variables. I use black for kind of bits and pieces like this. And I use red normally for stored values. But it's not necessary. And I also put commands in capitals to just distinguish, like they've done here. Is it necessary? No, it's not. Okay. So here I put in the number of eggs. Now I need this to keep going around until the number of eggs is between 1 and 8. So I'm going to use a repeat. So I'm going to repeat these lines of code. And then at the bottom here, until it's met the condition I want. See? And you see I've indented these 2 bits of code because these are the bits inside my loop. Well, until what's the case? Well, until eggs is greater than, now I could say greater than or equal to 1 or greater than 0. I'm going to say, let's say greater than or equal to, so that's that, 1. And then I also need to consider eggs is a less than or equal to, because it does include up until the maximum number of eggs that can be used is 8. So I can use 8 up until 8 eggs. Now the question is, what's the join that goes in between this? Now I could put in, for instance, I could say or. Now if it's or, if I put in, say, 5 eggs, is 5 equal to or above 1? Yeah, it is. So it'll finish. So that was a legitimate one. Is 10 eggs okay? No, 10 eggs. No, actually, let's go the other way. Let's do negative. I've said minus 5 eggs. So I put minus 5. Is minus 5 greater than or equal to 1? No, it's not. So that would be false. But is minus 5 less than or equal to 8? True. So it'd still be the case. So what we need to say is it's not just a case of or will need to be true. And so the way we'd write it is we'd say, and it's true. And so what's going to happen is it's going to keep asking these questions until this happens. The developer wants to use validation to ensure the user can only enter a positive number of eggs. Boom. The maximum of eggs is used as 8. Boom. Develop an algorithm to ensure the user is made to re-enter the number of eggs until a valid number is entered. You just tune in. Oh, done. Piece of cake. Okay. In this next problem now, it's going to be making use of a subroutine. So this is a snippet of code that we can call and run called code to char character. This can be used to convert a character code into the corresponding Unicode. So do you remember we talked about earlier about ASCII and Unicode? Well, if we put the number 97, it will turn it into a lowercase a. If we do 98, it'll be a lowercase b. If we do code to car 65, it will be an upper A, 66, capital B, etc. Okay. The other way around, car to code, so lowercase a, will become 97. Car to code B will return 98, and so on. State the value that we return from the subroutine call of this. So card to code E. So if A is 65, we can just take our time to write it out. We're in no hurry. So we can say A, B, C, D, and E. We can see here that A is 65. So we'll write 65 down for here. And then we can see B is 66, C is 67, D is 68, and E is 69. So that would return 69, but plus 2. So the value that you would get is 71. And then code to car, so taking the code of 71 turn it back into a character. If 69 is E, 70 would be F, 71 would be G. So it would return G. Right? Because car to code E would return 69, add 2 to it, be 71, and you can see 70 would be F, 71 would be G, returns it there. Okay. Next, we're writing a subroutine. So write a subroutine to lower. So this way, it takes an uppercase character as a parameter. So it takes in a uppercase character and returns the lowercase version of it. For example, to lower is past the character capital A and as a parameter, and it should return A. Okay, great. You should take the use of the subroutines code to car and char to code. So for a subroutine, I'm sorry I don't have it written with me right now, but to start off, you literally write the words subroutine. The next thing you need to write down is the name of the subroutine. And you see you've got it here, to lower. And we want to write it out exactly as they want to do. So to, lowercase, lower. All in capitals as they've said. Then it says it's taking in a character here. So I'm going to open up parentheses, and this is where the parameter will be here. So I'll say it will be, I need to give it a sensible name. So I can call it, let's call it char. So this is the value coming in. Maybe it's an uppercase D, maybe it's an uppercase F, whatever. Char comes in here. Now, do you see that what I'm going to need to do is if I receive a capital A, to turn it into a lowercase a, I'll have to turn it into a number, 65. What's the difference between 65 and 97? So we have to look at the difference. So 97 take away 65. So that's the difference in those two numbers. That's going to be 32. If my math's not wrong. So you take in char, you'd run car to code of it. You get the number, so 662, 65 in this case. Then you'd add 32 to 65 to make 97. And then you go code to char. 97, return it. So in here, we're going to say, first of all, we're going to run the first one, which was char to code. So we're going to call char undercase to lowercase or undercase. No? Yes. And then we're going to call it. And what we're going to send it, we're going to send it this char as a parameter here. So that's going to be char. I've written it too large. This is not sensible. I should have been a bit more careful. Oops. Let's tidy that up a little bit, shall we? Let's be a bit more consistent. Now, remember what that's going to do is it's going to give you this number. Now, do you remember we said we need to add 32 to this to turn it into a lowercase, so plus 32. And maybe what we need to do is store that. So this is going to be a bit ugly. I should have indented this whole thing, but I'm a bit low in space. So I'm going to say, let's call this upper. And there's an arrow pointing towards it. So what's going to happen? Char comes in here. So let's say, for example, a B gets put into here. Then it's char to code B, so in here, and that would return 66. 66 plus 32 is going to give you 98. And then 98 is going to be stored. So upper is going to be 98. I then need to get 98 and then turn it back into a car. So here I can say, I could call it, next one maybe is upper C. What's that going to be? So that's going to be the other one. It's going to be code to char. And I'm going to send it the number. So I'm going to send it a number like here. I'm going to send it this number because this is actually going to be our number we're using. And I'll call it upper. I'll call it upper. I'll invoke upper. Now that will be our actual character. So then to finish off our subroutine, the last thing I just need to do is I actually just use the command return. And what will I return? I'll return this thing here because that will be our letter. Oh no, that is so silly. I've given this silly names because I called it upper C. It's not, is it? It's turning into the lower number. My apologies, guys. So we'll call it lower. And then I'm going to call this lower C. Now, this won't change the functionality, but you should always use appropriate names for variables. So writing upper would be confusing if I came back later. So a clear and unambiguous identifier is really smart. And then here I can return, in this case, lower C. And then I'll go end subroutine. There you go. I think really I wouldn't have done subroutine here. I've not read the problem, so this is probably in the wrong place. So if this has thrown you, we'll do some more selection problems next. So sorry about that. Okay, so we're going to make use of iteration now. We're going to make use of loops. And so remember, we've got repeat until loops, while and while loops, which are for indefinite iteration. And then we have for loops for definite iteration. Now, in this case, what we're actually going to be doing is we're going to be having a look at this trace table. And this trace table is going to be of the variable total size, data to be sent, and number of packets. Data table is very common. And so it's not asking you to do the code right now. It's asking you to see if you understand the code. Now, constant payload size 250. Why is that constant? Well, it can either be a constant or a variable. The clue is in the name. Constant payload size, that means that it's always 250. You can't change it. If you remove the constant, it becomes a variable and you could change the size. So you use constants for values where you're not going to change the value associated with it. Okay, so we've got payload sizes 250, header size is 50. And FYI, that's why it's not going to be in a trace table because it's not going to change. You only trace the variables. Okay, output, enter the number of bits of data to be sent. Data to be sent, user input. So that person's put in 750, so that's where that came from. Total size is payload size plus header size. Payload size is 250 and header size is 50. So 250 plus 50 means that total size is going to be 300. Ooh. Yeah, that's pretty clear, 300. Okay. Okay, what's next? Number of packets becomes 0. So in here, I'm going to put 0. Now, you might have wondered, why didn't I write it here? In theory, you should always read left to right in rows like this. I don't need to change that to 750 because it hasn't changed. You only need to change a trace table if the value changes. Okay, next thing, repeat. Data to be sent is data to be sent minus total size. So data to be sent is 750. Take away total size, which is 300. So 750, take away 300 is 450. And then we sign it back. So then that becomes 450. And remember, we're in a repeat. So it's repeating until something happens. Next is number of packets is the number of packets plus 1. The number of packets was 0 plus 1. 0 plus 1 is 1. Restore it back in there. So that becomes 1. What's next? until the data to be sent is less than or equal to 0. Data to be sent is 450, so it's going to come back to this point here. Data to be sent is data to be sent minus total size, so 450 minus 300, so that's become 150. What's next? Number of packets is number of packets plus 1. Number of packets is 1 plus 1. 1 plus 1 is 2. Is the data to be sent less than or equal to 0? Nope, it's 150, so we come back here again. Data to be sent is data to be sent minus total size, so 150 take away total size, which is 350. 150 take away 300 is going to be minus 150. And then number of packets, which is 2 plus 1, so 3 is the number of packets, and number of packets is 3. Data to be sent less than or equal to 0. Yes, it is. Algorithm finishes because there's nothing else here. State why both payload size and header size from the algorithm did not need to be included in the trace table. What was I? To be consistent, I was using blue. So I would say something along the lines of these a trace table. These are constants, and therefore the value won't change. These are constants, so the value won't change. So what would be the point of tracing them if they stayed the same? Okay, shaded one lozenge to show which of the following best represents the input and output from the algorithm. So what are the inputs? So what is input? When the user enters the value 750. So the value 750 was the input for data to be sent. So input data to be sent. I think straight away we're in a pretty good place. And one of the outputs is certainly going to be probably the number of packets. Input the number of packets? No, that's something that we're generating as we're going along. And output the total size? No, total size was a set thing. And then input total size? No, we got this from here. It wasn't an input, it's something that we started with, and output was data to be sent. So I think input data to be sent because the user inputted that. So it's going to be that one. Onwards to the next one. Again, more problems making use of iteration. And now we're getting to the point now we're going to have to write some of our own code. An application allows only 2 users to log in. Okay. The usernames are stated in table 1. So the username Gower, and that's their password. Username Tough, that's their password. Develop an algorithm using pseudocode or a flowchart that authenticates the user. Now, authenticate means it's proof that you're who you say you are, so that the username and the password matches. The algorithm should, and so they decomposed it for us. That's very kind. Get the user to enter their username and password. Check that the combination of username and password is correct. And if so, output the string access granted. Get the user to keep re-entering their username and password until the combination is correct. Okay, so we'd use a for loop when we know how many times somebody would need to do a repetition. In this case, we need to keep repeating the loop until we get the answer. So that you can either use while or repeat. In this case, I think I'll repeat the algorithm. What do I need to do? Well, I need to ask the person to enter the username. So print. So this is a message for the end user. Please enter your username. And then we're going to store their uname, assign. And do you remember the function to get the input from the user? That's right. It's user input. The next thing is we're going to want to ask them to enter their password. Once you've asked them to enter the password, then you're also going to want them to store their answer in a variable. I'll call it p-word, same as before. Great. Now, I'm going to want to keep this going until I've got this match or this match. So until, now this will be a bit of a trickier one to write. I can't say until either username is Gower or Guff or password is this or this. I have to match them up. So I have to match the username to this and this. So this and this, or this and this. So let me write the first one. Let me narrate it. So uname is going to be the logical comparison equal, and then I can say Gower and P word is again equal to, and they're not either of these, the one it matches up to, that one. So it's equal to, I'm putting these things here because I assume it's a string. So I have to write it. So 9F DG3. So it's this and this. And then what I would say is, inside parentheses, so it's that and that, or, and then I'd have to do the other combination it could be. So it's username equals, and so this time I need to look at that and that as a match. Be careful to write it so it's all case sensitive, and then it's and P word equals, and remember it's going to be the one that matches it, so the one over there. Got to be a bit careful because you see I've put this and this inside the parentheses, so it's all of this together, or, and then I should do the same here, all of this and this in parentheses, in brackets, so that they're separated. This will keep running until either that combination or that combination is found, and then it should output access granted. So if I put down here, print, the only way you'll get to this line is if you actually terminated this loop, and this would only happen if you got a match, and I have to do the message exactly how they wanted. It was going to be access granted. Now, there would actually be other ways to do this as well, but that is certainly one of the ways you can solve this problem. Okay, this is a 9 marker, so quite a big question, but actually I don't think it's necessarily adding that much more complexity. It's just, longer, more broken up, but using all the same thinking as we did before. Again, it's going to be using iterations, so loops. In this one here, it says develop an algorithm using either pseudocode or a flowchart, so we'll be using pseudocode in our case, that helps an ice cream seller in a hot country calculate how many ice creams they are likely to sell on a particular day. Okay, so that's the goal of our algorithm. And we can now tackle it bullet point by bullet point. We can read through it all potentially, but it's really nice they've bullet pointed it for us. They've basically decomposed and abstracted the problem, which is great for us. Get the user to enter whether it's the weekend or a weekday. So, technically, I'm a bit anxious because I'm a bit low on space, but technically, I probably should ask the question, first of all, to ask them whether it's a weekend or a weekday. So let's try that. So I'm going to ask, is it a weekend? And I'm going to assume they're going to respond yes or no to that. Probably should validate, but it doesn't require it. And so then we'll store that inside a variable called week, and we'll put the assignment there. And do you remember what it is for a person to put an input, an end user? That's right, it's the command user input. And I'm assuming that this will be either, is it a weekend? Yes. So that'll store a yes. Is it a weekend? No. I'd be a weekday. Okay. Get the user to enter the temperature forecast in degrees Celsius. Okay. They should enter a number between 20 and 45, inclusive, i.e. it can be as low as 20 and as high as 45. If the number falls outside of this range, they should be made to re-enter another number until they enter a valid temperature. So we're going to need to repeatedly ask them until they get it right. So we can either use a while loop or repeat until. I think repeat works quite nicely here. So we can say repeat, and then we'll say, we'll get them to enter a temperature. So I'm going to ask the question to print a temperature. I'm anxious of running out of space, but probably it should say, it would be better if it said between 20 and 45. So please enter temperature between 20 and 45. And then we'll say temp, Again, user input as before. So we're going to get the person to enter it in here. And remember, you want to keep looping around until something becomes true. In this case, until what? Well, until temp is greater than or equal to 20. Remember, this is one of the places you can go wrong. And temp, in fact, let's go wrong here just to prove the point. Temp is less than 45. Now, if you do this, what's going to happen is if you actually put 45, 45 is not less than 2045, so it would fail. So you'd have to say less than or equal to. Potentially you could say less than 46 if you're only putting whole numbers in. But if it's not just whole numbers, you could put 45.9 and it would be wrong. So I guess that's the trade-off. Okay, we're now in this bit here. So this looks like one of the more substantial bits of the algorithm. Calculate the number of ice creams that are likely to be sold using the following information. Okay, if it's 100 ice creams are likely to be sold if the temperature is between 20 and 30. Right. If it's between 31 and 38, it's 150 degrees. And if it's higher than 38, then it's 120. Okay, so what we could do is there's 3 different outcomes. Now, if there was 2 outcomes, we could use a selection statement of if and else. In this case, because there's 3, we should use if, else if, and else. So if what? Well, if we're checking if the temperature is between 20 and 30. Now, you can't put a number lower than 20, right? So we're saying if temp is between 20 and 30 inclusive. So if you said less than 30, right? You're not including 30. So again, you'd have to say less than or equal to 30. Well, then if it is, then what? Well, then why don't we initialize ice creams? So I creams is going to be set to assign the value 100. And then else if, so what's the next thing we have to worry about? We have to worry about this one here, between 31 and 38. So we can say if temp, we've said if it's 30 or lower, it's already this. So now we can say if temp actually is less than or equal to 38, because remember it has to be inclusive of 38, then what do we do? Well, then we set I creams now, instead of being equal to 100, what does it say it's going to be? Let's have a look over here. It's 150. So now we've got 150 ice creams. Now for the last one, you don't have to do else if temp is greater than 38. You can just say else. Why can you just say else? Well, because it's the last one left. So we can say else. I'm going to have to do something a bit silly here and write it up. I should write it down here, but I'm running low on space, which I'm a bit anxious about. So I'm going to write it up here. My apologies. It doesn't change the way the algorithm works. It just makes it look a bit ugly. In fact, gosh, the way I wrote that was pretty horrible as well. So I creams, let's look at the last one here, is 120 if it's there. Oh, you'd have thought it would be higher again, but it's not. It's 120. Okay. Double the estimate if it's a weekend. So we'd have to say in here, if, oh, sugar, we should write here, and if, for all of this statement, oh, I'm really going to be low on space. So if what? If weekend, remember this is the thing we did right at the beginning. If weekend is equal to, so if it's the weekend, we should double it. So if weekend equals yes, then, did it say we had to double it? Yeah, I think it did. So we'd have to say in here, oh gosh, I'm going to zoom in to allow me to do this. If it looks a bit small, it's my apologies. I guess you can see it fine, but when we zoom out, we say iCreams, whoops, is assigned iCreams, and this time we times it by 2. And then we should, it should end if, but I'm out of space, because the last thing I need to do is actually output the number of ice creams that I'd like to be sold. So the very last message is print in this case, actually output, what's the message? We can just put in here, I probably should put a whole message, but I'm running low on space. So output iCreams. Apologies for going a bit ugly at the end. I had to sort of squeeze it in there. Okay, another pseudocode problem, similar kind of idea again. You can see that these all have a certain theme. Hopefully I won't have to squeeze it as much as last time. It's an 8 marker rather than a 9 marker, but it'd be pretty similar, I would imagine. Develop an algorithm using flowchart or pseudocode. It's for a taxi company to calculate a fare. So last time it was ice creams, this time it's a taxi fare. And again, very helpfully, they've broken it down for us. Prompt the user to enter the journey distance in kilometers. So I should actually prompt, so I should say, I keep writing print, maybe output's the right thing to say. I'm marking this, right? So if you put output or you put print, I know what you mean. So output, enter distance in kilometers. Now, I probably should have read on a bit more because it says that it has to be greater than 0 and the user should be made to re-enter until the distance is valid. So you don't know how many times they're going to get it right or wrong. So it's going to be indefinite again. So at the top, I'm going to put repeat. The person's going to enter it, and I'll say, maybe I'll put down here kilometers as the variable, user input, and I have to keep repeating this until the actual user input, until the kilometers is, in this case, positive. So until is greater than 0. So until kilometer is greater than 0. Brilliant. And it'll keep asking the question. I mean, it might be better. I said enter distance in kilometers should be greater than 0. But I'm a bit low on space. Prompt the user to enter the number of passengers. No validation required. So I can just ask the question and then take the value in. So for this problem here, I'm going to ask him how many passengers, and then I need to store that. I'll call it pass, and then assignment, and then user input. And then I've stored how many passengers there are into this one here. Okay, great. Calculate the taxi fare by charging £2 for every passenger regardless of the distance, and charging a further £1.50 for every kilometre regardless of how many passengers there are. Output the final taxi fare. So it's £2 times by pass plus £1.50 times by kilometres. So I'm going to use fare to calculate this whole thing. So fare is going to be assigned £2 for every passenger, regardless of distance. So that's going to be passenger times by £2. So let's say times by 2.00. In fact, it'd be good to put that in a bracket. Plus £1.50 for every kilometre. We've got how many passengers. So times by plus kilometre times by 1.50. I'll be honest with you guys, I really thought I was going to run a bit low more on space. And then so finally output, plenty of space in the end, a few output, and then you could output fare. And that'll be the calculation of the fare. I think it was a lot easier than the last one, to be honest. I guess it's 1 mark less. Okay, in this problem now, we're going to be making use of definite iteration. That's iteration when you know how many times it's going to go around. Typically, you do this with a for loop. In this problem here, we've got an algorithm shown in figure 4 and figure 5, and both have the same purpose. Remember, an algorithm is a set of instructions to achieve a goal, and both of figure 4 and 5 have the same goal. The operator left shift performs a binary shift to the left by the number indicated. Remember, if you go shift by 1, you double the number, shift by 2, you times it by 4, shift by 3, you times it by 8, and so on. For example, 6 left shift 1 will shift the number 6 by 1 place, which has the effect of multiplying the number 6 by 2, giving 12. Okay, and so here's 4. The other one is going to make use of a for loop to do it. Okay, complete the trace table for figure 4 when the initial value of number is 4. So number is 4, left shift by 2. So left shift by 1 will be timesing it by 2, but left shift by 2 is timesing it by 4. So result, first of all, is going to be number. So that's 4 times by, and then it will be times by 4. So it'll be 16. So the original one here is 16. So that's this value here. And then it's result minus number. And number is still going to be 4. So in this case, it will be 12. Okay. Complete the trace table for the algorithm shown in figure 5, when the initial value of number is 4. So on this one here, the first level is, it will say result is 0, and which is here. Then x is 1, and it'll be x will be 1, then it'll be 2, then it'll be 3, and then it'll be the end of the for loop. So x is 1, then it says result. Result is result, which is 0, plus number. So that will be 1. So result, oh, because number's not being input yet. Number's still 4. So result, which is 0, plus number, which is 4. So it will be 4. Okay, so what's next? Well, next is x becomes 2. So x is 2. And then it will be result, which was 4, plus 4. So it will be 8. And then it will be 3. And when it's 3, it's result plus number. So it's 8 plus 4. So it will be 12. Okay. Then it says state the purpose. Well, if you put in a 4, then it's the equivalent of timesing it by 3. And whatever number we put in, you are going to have it multiplied by 3. In this case, the first thing that happens is you times it by 4. And then because it will take a number away from itself, it will be times by 3. While the other one, it's 1 times the number, 2 times the number, 3 times the number. So the answer would be, in this case, multiply number by 3. Okay. And then it says, explain why the algorithm in figure 4, so this one, can be considered to be a more efficient algorithm than 5. Now, efficiency is where we've come up before. Do you remember we talked about binary search versus linear search, and that binary search is more efficient than linear search when there's a large number of items, because you don't have to have as many instructions. So you see here, it takes more instructions to find the answer using figure 5. So what's the answer? We write it out now. So we remember with an algorithm, the definition was a set of instructions to achieve a goal. Figure 4 requires less instructions to achieve the goal, and therefore is more efficient. Okay, we're now looking at arrays. And earlier we looked at strings, and we said that a string had an index and at position 0, 1, and 2. And in this case, we have an array, which is a collection of integers. Now, it's worth remembering that in an array, it also has an index, and that will be at position 0, position 1, position 2 inside that array. Okay, let's have a quick read. So, in this case, it says array indexing starts at 0, right? So 0, 1, 2, and you can assume that's always the case. There's an array called R, storing values 4, 1, and 6. So it's a one-dimensional size 3 array. Then there's a variable called sorted, set to false. It's saying in a while loop, so an indefinite loop, while sorted is still false, first set sorted to true, then set I to 0. While I is less than 2, then you can do a bunch of stuff inside here. All right. Let's keep going. State the data type of the variable sorted. So sorted is set to false. We did something very similar to this right at the beginning. If you remember, that is a Boolean value. Okay. This one, I don't know if you recognize it, but it's saying if that one here is smaller than that one, if that one there is smaller than that one there, then create a temporary and essentially swap them over. I don't know if you remember, but that's actually a bubble sort. The identifier sorted is used in the algorithm shown in figure 2. So here, explain why this is a better choice than the identifier S. Brilliant. So this is a programming technique, same way why you'd want to indent the code. It makes it easier to understand what the code does, and for other people to understand what the functionality is as well, even yourself when you come back later. So let's write the answer. So sorted, the name of the variable, describes the purpose of the variable. Putting S wouldn't describe the purpose. That can mean anything. And that's going to make it easier to follow and understand, both for you when you come back and using it, or for somebody else to come back and using it. You should always have meaningful identifiers for variables, for arrays, for subroutines. Okay, the same algorithm from before. And remember, we said that this was actually going to be a bubble sort, which might be a bit of a giveaway. This time, we're going to have a trace table. But first of all, we've got to shade one lozenge to show which of the following contains the false statement about the algorithm. Okay. The algorithm used a name constant. Do you remember you have a constant versus a variable? There are no constants there, so that actually is false. But let's do the rest. The algorithm uses indefinite, so that while sorted, that's indefinite, iteration. So it does use it. The algorithm uses nested iteration. Brilliant. You see here, that's iteration, isn't it? And that while loop is nested inside. That if statement is nested inside the while loop. So that top one there, it does not have a constant. All right, this is the trace table. Let's get it done. So 416, so that's bit here. Sorted is false, so it's there. While sorted equals false. Sorted is false, so continue. Then the first thing that happens is that sorted becomes true on this line here. I becomes 0. While I is less than 2, 0 is less than 2. If array at position I plus 1. So remember, I is 0. So array at I plus 1 is going to be here. It's going to be the value 1. Is 1 less than array at 4? So is array at plus 1, so is 1 less than 4? Well, 1 is less than 4, so then t is r at I. So remember, I is 0, so array at position 0 is 4, so t becomes 4. I becomes, what's at r at I plus 1? So this is r at I, so it's 0. 0 plus 1 becomes 4. So that variable there gets put in here. So that's become 1. Array at position I plus 1. So remember, I is still 0 at plus 1. So at 1 becomes what's been held at t. So 4 gets put into that box there. So this is the swap that you get in the bubble. And then sorted, sorted becomes false. So that's switched back to being false. And the if, I is I plus 1. So I becomes 1. Great. And then m while, and so you come, but you don't go back to this while, you come back to the one that's indented at the same place, so back to here. Is I less than 2? Well, I is 1. Is 1 less than 2? Yes, it is. Is so I is 1, so 1 plus 1 is 2. So R at position 2, so 6. Is 6 less than 4? Is 6 less than 4? 6 is not less than 4, so you don't do any of that. And if I becomes 2. And then it says, m while, come back in here, is 2 less than 2? 2 is not less than 2, so that while loop stops, so I come back to here. Is sorted equal false? Sorted is still false, and so now it says sorted becomes true. So that becomes true. I becomes 0. While I is less than 2. Is 0 less than 2? Most definitely it is. Is r at I plus 1? So is 4 less than is 4 less than 1? Is 4 less than 1? No. So I becomes I plus 1. So that becomes 1. And then it will come back here. Is 1 less than 2? 1 is less than 2. I is 1, so is 4 less than 6? Sorry, is 6, sorry. Is 6 less than 4? No, it's not. So we don't do any of that. I plus 1 becomes 2. Is 2 less than 2? No. So while loop terminates, come back here. Is sorted, while sorted is false. Is sorted false? No, sorted is true. And then it's going to end while. And you can see here what's happened is that it's become 1, 4, 6. So it's actually sorted the list. Okay, earlier we actually looked at subroutines when I didn't mean to. But essentially, subroutines are bits of code that are broken up so that you can write them separately. Remember, there's a bunch of different advantages. You can reuse them multiple times. You can package them up in a library for somebody else to use. You can split up in a team so different people can work on different subroutines. They're easy to debug because you can test them individually. So they're really useful modular programming. In this case, what we write is the word subroutine, the name of the subroutine, whatever parameter values, and whether it returns a value or not. This is simply asking you to use all this to figure out how it's going to work. You've got 4 subroutines. You've got main, which receives 1 parameter value. You've got decrease, that receives 1 parameter value, increase, that receives 1 parameter value, and is even. And these are all working together. So really, it's the skill of seeing whether you can see how they all work together here. We're going to use a trace table to see it in action. So complete the table showing all of the outputs from the subroutine call main 3. So the first thing that happens is that you call main, and k is going to become 3. The first output's already been written because it says output k. You may not need to use all the rows of the table. Okay, so while k is bigger than 1, and we need to show every output. Well, k was 3, so 3 is bigger than 1. If is even k, so is even is here, so now that's going to receive 3. Is 3 mod 2, well, 3 mod 2 is going to return 1, so it's going to return false. So is that going to be false? Is going to be is false is true? Well, it's not. So that's not going to happen. So it's going to come down here. God, this is getting quite confusing already. Maybe we'll just back up a moment. So let me do it maybe with drawing some arrows to make it clearer. So that k is 3 because it came from here. Is 3, so k is 3 at this point. In fact, maybe I'll write it next to it. So k is equal to 3. While k is bigger than 1. Well, 3 is bigger than 1, so there. If is even k. So the k gets sent to is even, which is down here. And then n, in this case, is going to be equal to 3, right? Because n received what was in k, and k was 3. 3 mod 2 will return 1. So is 1 equal to 0? No. So it's going to return false. So false is going to come up here. Is false equal to true? No. So then k becomes increase k. So k is still 3. So 3 in this case, so increase, where are we increase? So n is still 3. So this is 3 times n, which was 3, so it's 9, plus 1 is 10. So result is 10. So 10 gets sent back here, so k now becomes 10. So k is equal to 10. And then it even says to output k. So output 10. Then it says, is k bigger than 1? Well, k is now 10, so that is definitely bigger than 1. Is even k, so 10 gets pent to is even. N is now 10. So we can say n is 10. Is 10 mod 2? That's going to return 0, so it's going to return true. So that will return true. And now it says k decrease by k. So k is still 10. Okay, so 10 is going to send to decrease. And there's a result of 10 div 2. If you remember, div is integer division. So that 10 div 2 means that return 5. So that will go here and k will become 5. And then it's going to output k. So k was 5. So the next output is the number 5. Right. So 5 got outputted. Then we come back in here. Is k bigger than 1? Well, 5 is bigger than 1. So is even, right? So that's going to return if it's even, which you know it won't. So it's going to be here. So k is now increase k. So 5 goes in here. So that's 3 times 5, because, you know, k is 5. So n becomes 5. So that's 15 plus 1. Comes back in here. K becomes 16. And then you output it. So k became 16. And here it's outputting it. So here it becomes 16. Okay. And then it comes back here. Is k bigger than 1? Well, k is 16, so definitely. Is k even? So k will come down here, and you would find that 16 mod 2 will be 0, so it return true. So k then gets decreased k, so 16 gets sent in here, so it's divided by 2. So now k is 8. I've stopped updating it to these ones here. It's getting a bit messy. Okay. And then we come back in here. Is 8 bigger than 1? Yes, it is. Is it going to be even? Well, it will be, won't it? Because 8 mod 2 is 0, so it's going to be true. So it's decreased by k again. Decreased by k means it'll be 8 divided by 2. So that'll be 4, and then you output it. So it'll be 4. Is 4 bigger than 1? Yes, it is. Is 4 going to be even? Well, 4 mod 2 is going to be equal to 0, so it will be. So decreased by 2, so 4 div 2 returns 2, which will then output. And then is k bigger than 1? So k is 2, so 2 is bigger than 1. Is it even? It will be, because 2 mod 2 is equal to 0. K decreased by 2, so 2 div 2 will return 1 on the output. And then finally here, is 1 bigger than 1? No. So that's the end. That is reasonably tricky. Easy to get lost. Okay, this is a question where it's now combining subroutines and arrays and the concept of authentication. Remember, authentication is when a user proves their identity, could be through biometrics, but in this case with a username and password. We start up over here. In fact, I might zoom in a little bit for us to see. Oops. Just because there's a lot on screen at the moment. Hopefully that will work nicely for us. Okay, so we've got, array again starting at 0. So that'll be at position 0, position 1, position 2, 0, 1, 2 for the 2 arrays. At a glance, how do we know they're arrays? Because they've got these square brackets. Line numbers are included but are not part of the problem. Absolutely. So subroutine, identifier, authenticate. It's got 2 parameter values, user and pass. We've got these 2 sets. These must be a collection of usernames, and these must be their corresponding passwords. So username Dave, password ABF32. There's some stuff here where you've got a variable called z equals 0, correct is false, and then that must be the process you go through to check if they're right. All right, why don't we do the trace table together? So first thing that happens is that it wants you to check z and correct. So z is 0, so we can put that in here. And correct is false. You see that directly underneath it? I'll point it out just in case. See, false. Okay. While z is less than 3. Well, z is 0, so 0 less than 3, most definitely. So if user equals USZ, so what position 0 on US? So that's Dave. So if user equals Dave, well, we don't know that at the moment. Oh, yes, we do. I've totally forgotten to read this. User is Alice, right? And password is woof 2006. My apologies. So is Alice equal to user at position 0 Dave? No. So terminate. And then z is z plus 1. So z is going to increase by 1 or increment. Is z less than 3? Yes. User, so Alice, is equal to US, but now at position 1. So Alice. Is Alice equal to Alice? Yes. Is pass, so woof 2006, equal to pass at position 1? Yes, it is. So correct equals true. And if z is z plus 1, so z will go up by 1, so 2. And then in here is z less than 3. Well, 2 is less than 3. So users at US position 2. So is Alice equal to Bob? No. So terminate that. And then z becomes 3. Is 3 less than 3? No. And wow, return correct. So it would return true. Okay, let's go to the next one. State the value that is returned by the following subroutine call. So if we send Bob, there you go, and ABF32, what's going to happen? Well, the problem is Bob is in position 01 in position 2, and Bob's password is this. So what's going to happen? Well, corrector set is false here. It's only going to become true if you have a match between that one and that one, that one and that one, and that one and that one, which it doesn't. So it's going to return false. Okay. Where were we? Line 7 and 8. So the if and this one could be replaced with a single line. Shade one lozenge to show which of the following corresponds to the correct new line. Now, before reading it, what we've got is an if statement, and nested inside it is another if statement. The function of that is to use an and. So, because it's like to get to this point here, this has to be true, and this has to be true. So we're looking at something with an and. Now, it's not going to be or, so that's an and command, and that's an and. If user equals USZ, yes, and pass equals PSZ, it is that one. Because this one is saying if it's the opposite, so it's going to be that one there, because both is basically saying on this argument that both would have to be true. Okay, a programmer implements the subroutine shown in figure 3, so this one. He replaces line 9, this one, with return true rather than return false. Explain how the program has made the subroutine more efficient. Now, you might have felt a bit frustrating that we'd found it true, and yet we still had to evaluate the rest of the list. Okay, that is kind of inefficient. By going return true, you'd stop the algorithm at that point and it wouldn't continue. So you wouldn't have to do any more tests. So what you would do is that it wouldn't have to continue to check once it's found it. It would stop at that point, which would make it more efficient. So the program would return true as soon as a match is found. Otherwise, you keep having to go over the rest of the array. And so there's going to be no need to keep on checking out the rest of them unnecessarily. So you wouldn't have to check the rest of the array, and you could say unnecessarily without necessity. Okay, this is quite a long and involved question. You read a question like this, and it can actually throw you a little bit with just how much is being asked of you to understand. But you apply the concept of decomposition to try and break this idea down into more manageable chunks to be able to answer this question. to get us started, let's just start having a read. A developer wants to simulate a simple version of the game of battleships. The ships are located on a one-dimensional array called board. So that's just a list. There are always 3 ships placed on the board. One carrier has size 3, one cruiser has size 2, and one destroyer has size 1. The size of the board is always 15 squares. A possible starting configuration is shown below. So it's 0 to 14, so 15 different values. And the ones that are shaded in black here are the different ships. So that's your carrier, that's your destroyer, and that's your cruiser. Okay, for example, the carrier, for example, is found at locations 1, there you go, 2, and 3. A player makes a guess to see if a ship or part of a ship is located at a particular location. So picking a number between 0 and 14. If a ship is found at the location, the player has hit the ship at this location. Every value in the board in the array is 0, 1, or 2. So a 0 is represented to an indicate. So this bit where it's sort of white, that's a 0. 1 is if a ship is at this location, so that would be a 1. And 2 is if it's been hit. Okay. The developer identifies one of the subproblems and creates a subroutine shown. So here's a subroutine F. Terrible, terrible name. It takes in the board, so it takes in this array, takes in the location you want to hit. Board at that location, so the position between 0 and 14 is position H. And then whatever's held there, if it's a 1, that means it's a ship. Otherwise, there's nothing there, or it's already been hit. Okay. The subroutine in figure D uses the values true and false. Each element of the array board has the values 0, 1, or 2. State the most appropriate data type for these values. So even this super complicated question, it starts off actually not too brutally. So true and false, that's going to be Boolean. And 0, 1, or 2, well, that's going to be integer. There you go. The developer has taken over the problem of the game Battleships and has broken it into smaller subproblems. State the technique that the developer has used. All right, we understand this. When you have a big idea and you break it into a bunch of smaller ideas, that is decomposition, as opposed to abstraction. An abstraction was when you remove unnecessary complexity to let you focus on, or unnecessary detail to let you focus on the important pieces or the important bits. Okay. The identifier for the subroutine in figure 10 is F. This is not a good choice. We said that. State a better identifier for the subroutine. Explain why you chose it. So F is finding whether there is a boat there. Right? Isn't it? Because it's saying sending the board, sending the location you want to check, and if it's a 1, it's seeing if the actual item is there or not, or if there is a if there is a ship there. So my name I'm going to give to the identifier is ship found, because I'm saying if it's found at there. What's my explanation? If ship found and unhit. Because if it's hit, remember it would be a 2, return true. And if it's not hit, if it has been hit, it'll be a 2, and if it's not there, it'll be a 0. So it's whether you've actually been able to make a hit for this one here, whether you've actually managed to find a ship to hit. Okay. The variable h in the subroutine in figure 10, h, is local to the subroutine. State 2 properties that only apply to local variables. So this is local versus global. A global variable is visible throughout the scope of the entire block of code, so visible in all subroutines, while a local variable is only visible within the scope of the subroutine and also only exists whilst the actual subroutine is being called. So let's write those 2 down. First of all, local variable visible in scope of the subroutine. Local variable only visible in the scope of the subroutine. So in this case here, let's imagine that we had some other subroutines, H is only visible and accessible here. In another subroutine, it would not be available. So that's one of the points. What else can we say about it? Well, we can also say the variable only exists while you've called the subroutine, or while the subroutine is actually running. So part one, the local variable is only visible in the scope of the subroutine, whereas the global variable is visible throughout the scope of the code, in all of it. The local variable also only exists while the subroutine is running, while global variable is always available to be accessible. Okay, and this is the final question. So it's asking you to quite a bit here. It's asking you to understand the nature of the problem that's just been described and then implement a solution. And what it's doing is it's asking you to write a new subroutine. So we already exist this one here. We also need to develop a subroutine that works out how far away the game is from ending. So the subroutine should have a sensible identifier. Take the board as a parameter. So the array, this array here, it has to accept it as a parameter. Work out and output how many hits have been made. So you're going to have to go through the array and check to see where a hit has been made. And if you remember, a hit is stored as a 2. Work out how many locations containing a ship have yet to be hit. If there's 0, output a winner. If 1, 2, or 3, then say almost there. All right. It's worth bearing in mind as well that you start off with needing to make 1, 2, 3, 4, 5, 6 hits. So that's where you need to get to in the end to be able to make that decision. So anyway, let's start off by calling it the subroutine. So literally, you write the word subroutine to declare it as being so. The next thing is it's going to have a sensible identifier. The identifier should be basically describing what it does. So what do we need to do? How far the way is game from ending? How far from ending? There you go. It's like the Ronseal of identifiers. It says what it does on the tin. Now, it takes in one parameter, which is the board. So in here, we'll write in board. So it's going to take in the array board as a parameter. All right. Next thing is we need to work out and how many hits have been made. So we're going to have to go through the array and count how many times we've actually hit. It's taken a hit. So let's declare a variable here, hit, initialize it to the value of 0. And then we're going to step through the array and look for every position in the array where the board has been 2. Since we know how many times we want to go through because we know the size of the array, we should make use of a for loop. So we're going to use a for loop. So for, we use a counter or an index. I'll use I for index. I start at position 0. Where do we want to go up to? Well, we want to go up to the last position, which is 14. Alternatively, you could say board.length -1. Either way would work for our purposes because we know it's always going to be this size. So basically, you're starting at 0, then go to 1, 2, 3, all the way to the end, you get to 14. Okay. As we're going along, we need to check the board and we need to say if board, and then to check an individual position in an array, we use square brackets. At position I, so first time around it'd be 0, then 1, then 2. If that is equal to, so remember if it's a 2, it means it's been hit. So if it's equal to 2, then it's actually should be recorded as a hit. So we should take hit becomes hit plus 1. So we've actually increased the amounts of hits it's taken, and we've increased it by 1 every single time that's happened. What happens if we haven't got a hit? Well, it's either not there, right? Or, well, I would say that at the beginning, there's 6 things that could be hit. So you could either count every time there's a 1 and say that's yet to be hit, or yet to be hit could be 6 minus the total number of hits, if you see what I'm saying. Because if the number of hits is 0, then the number yet to be hit will be, oh, I say 6. Yeah, 6, right? Because there's 1, 2, 3, 4, 5, 6. There are always 3 ships placed, size 3, size 2, and size 1. So yet to be hit would be 6 minus hit. If you've hit 2 of them, then 6 minus 2, you've got 4 yet to be hit. So that would be this. We'll just go end if. And then we'll say the end the for loop. The default of the for loop is it always goes up by 1 every single time, so you don't have to specify for this. Where were we? Work out and output how many hits have been made. Okay, so output. And the message was hits. So that's how many hits have been made. Might be nice if we said speech marks, there has been plus hits plus made. Anyway. And then next it says, if there are, work out how many locations containing a ship have yet to be hit. So that would be 6 minus hit. If it's 0, then output the winner. So I would say, for this one here, we could say something along the lines of, if 6, which is the total number, minus, in fact, you know what? Let's take a moment to just calculate it. Let's do it separately. Sometimes there's a little less many. Yet to hit, right, is equal to 6 minus the number you've hit. Oh, poo. I called that hits. 1 second. I called that hits. So they should all just be hit. I put a plural in, which is technically the wrong thing. Okay. And we say if yet to hit is equal to 0, i.e. we've hit them all, then what? Well, then output winner. So underneath here, you'd output the phrase winner. You do exactly as they've asked. So winner. And we'll also say else if. What else could we check for? Well, we need to check if yet to hit is 1, 2, or 3. You could say else if yet to hit equals 1, or yes to hit equals 2, or yes to hit equals 3. I think it'd be easier to say yes to hit is less than or equal to 3. Right? And you could then say output. Gosh, I'm getting low on space here. Output almost there. Because if it was 0, that's going to trigger first. And then if it's 1, 2, or 3, it'll say this. And then otherwise, I guess you do nothing. I should write an end if here. And underneath here, I should say end subroutine. And then that'll be that finished.